Hello, everybody. This is Dorian and I'm Roman. We are from a really good company. Maybe you can see it already in the color, from Deutsche Telekom. And we're trying to talk about observability and how we do monitoring in Cloud Native Telco World and how we can tie this all together. Okay, let's look at our short agenda. The question is how we collect everything, how can we get the metrics, how can we evaluate them if we have them, what we do with them, of course, and of course an outlook to the future. Okay, here you can see our ecosystem we're talking about. You can see that there are multiple clusters from the Schiff. Thank you, Vuk. And as you can see, we we only do have 5G components, but you see there it's called MME. So the good old 4G, we want to support our customers there as well. And you can see also that everything is deployed via GitOps. So here, short icon for Git, right? And of course, this central instance where we push those metrics and logs and everything else in there is Mops. It's also a platform underneath. There's Elastic, so an environment to analyze those data. Okay, so what's observability? It's events, and we have different kind of events there. We have the logs, we have the metrics, we have some alerts, and of course, also really, really important, we have traces there. Okay. Next, we talk about each of the steps, about log shipping, metrics, alerts, and then we have a special guest, and then we'll pass now to Dorian, who's saying something about log shipping. Yep.
So, thank you. So for log shipping in Kubernetes, there's not a lot of ways. So the picture you see on the slide is taken directly from Kubernetes documentation. Basically, you have the option to run one sidecar per pod, collect the logs there, send it to some sink. Of course, it's possible that the application itself is able to stream to some sink, in our case, Elasticsearch. Unfortunately, not the case everywhere. Somewhere it's possible, somewhere not. So we need a more unified approach. And of course, you can also log to disk directly to the worker node, collect the data there and send it to some logging backend. As I said, the slide is directly from Kubernetes documentation, not really a surprise. We tried several of the log shipping agents available. At the start of the journey, we had FluentBit, and it just worked. It was fine. But our platform provider, Kubernetes as a service provider, which is das Schiff at Deutsche Telekom, wants to move to Vector, like a pretty new project. It's under CNCF umbrella. We had some trouble with it, getting it right, and then we moved to Filebit because we have at least 2 engineers who are really knowledgeable about Filebit, so we moved back to that one. But we're already planning to go back to Vector once we can and find a bit of time, but I'm not quite sure if the journey is at the end there or we need to iterate further, and maybe at the end of the day we will be back at FluentBit, who knows? Let's see. What are the problems? Why do we iterate through so many log shippers? Well, security is really a problem. If you really think it through, mounting the whole of Warlock containers or Warlock pods to some kind of application running inside the cluster, this is, of course, against need-to-know principles. And maybe we're able to get some audit logs. Maybe there's some stuff which should really not be in there and being sent to an analytics solution. And, well, a lot of open questions there because I don't see a perfect solution anywhere in the Kubernetes environment, to be honest, right now. Then, of course, what does the platform provider want to do? If they want to push Vector, we'll try to comply, obviously. And one more thing is support. As you may be aware, the company Elastic just stopped the support for their Helm charts, which we're using to deploy. So we have a small problem there. Let's see if we can solve that. And also maturity, because for Vector, when we started to use it for the first time, it was not possible to even send data to multiple endpoints. So if you have for high availability multiple endpoints, Vector was only able to speak to one of them. Not a problem in Kubernetes world, but in this case, application like the logging sync was running not on Kubernetes, didn't have the single endpoint, but had for high availability multiple, and Vector was not able to support that. there's more problems, but just scratching the surface here. So let's talk about metrics, different kind of beast, less in volume, like in terms of data storage, but still there's a lot there. So inside the box, we have the solution provided by das Schiff again. So of course they run Prometheus and the pods expose their metrics there. Thanos is a front end to query, and das Schiff is also providing Grafana, which is running per cluster. And if Grafana can get the data from there, of course, it's possible to scrape the entire data and send it to the logging solution again, which is Elasticsearch. And again, we had huge problems there with cardinality. Inside the Prometheus, we found something like 70,000 time series. And querying them and sending them to another thing is a problem because this is the memory usage of the Thanos that we are using to query. And you can see we tried to scrape just everything there and send it away. And Thanos was using like 4.6 gigabyte of RAM during the queries and then slowly getting back to normal. And we had queries that took like 20-something seconds to go through and send the data back to us. And if we want to query this data every 30 seconds, you can already see it's becoming a problem. If there's like, I don't know, 5,000 time series more, it's not going to work out. It's possible to mitigate some of that, but I think cardinality with the Prometheus is one of the hugest issues. I saw some interesting talks about it. Maybe we'll find some answers. And of course, there's a special type of events that are alerts. And for one, we've used, of course, Alert Manager from Prometheus to create alarms, but also I just picked this vendor out of multiple vendors that we have because it's already public knowledge anyways. Mavenir, for example, is creating their own alerts, and that's good. The software does it. The problem is how their alerts look like. What fields do they have? What metadata do they have? Is quite different from maybe the other alerts that we created in Alert Manager, and the problem is always how to unify it again. And having one central sink to do it in this case, Elasticsearch, and then create even more alerts out of alerts is one of the solutions. And one special type of event that we like, every Git commit to the main branch, which will result in deployment, is being sent there as well. So you can see these red lines, and the red lines indicate that at this moment in time, there was a commit to some cluster. So that means if you can see that something apparently is wrong, log volume increases like tenfold or something, but you see this red line, you at least know where to start looking. And I've talked about the huge differences in quality, about log formats and so on and so forth. And we found one special guest, which is quite helpful to have a more unified look at the things. And Roman will present about that one.
Okay, before I come to the special guest, I want to talk a little about our network functions. We, of course, have a multi-vendor network function system here. And the question is now, they need to talk to each other, but how we create how we can achieve some observability between them. So in the good old legacy world, everyone loves the PCAP, right? But if we look at 5G standalone, with all these new services, we have some RFC 1945. Does anyone know what RFC 1945 is? Raise hands. No one? Maybe you're too young. It's HTTP 1.0. So actually, HTTP is even older. And HTTP 1.0 is from 1996, by the way. Actually, 5G standalone, of course, is using RFC 7540, so which is HTTP 2.0 from 2015. Yeah, so we decided to put something in the middle to abstract those communication between those network functions, and we chose, for time being, Istio, for example. And the gray boxes here are showing the sidecars there, which allows us to abstract certain things, right? Like security and so on. And also with this sidecars there, we have the possibility to use tracing solutions like Zipkin or like Jaeger, for example. But our current way is we are trying to use the access log first. That means every message which goes from one network function to another will be logged. And here you can see an example of that. This is already as JSON because JSON makes it easier to parse that in a useful manner, especially if you have it in in Elastic, for example. You can see here it's the method, the protocol, the network function, the path it's using. So it was a registration message. You see if it was successful. You even have the duration. So lots of things, and you see here I put some dots there, and it's even bigger. And if there's an error like 400 message or 500, whatever, you would see then also a root cause there. Yeah, of course, if every message gives us a log entry, this means also it's from performance point could be a problem. Currently we are using this one. But maybe we are coming back to, or we are going forward to those more enhanced ways to use it for the SPI communication. Okay, then let's jump to evaluate all this data. And Dorian is taking care of that.
So we have a lot of data in all the places, and we have to see that the 5G, of course, is new. Maybe we have new vendors inside there. What do we do with the data? And the most important question is it working yet? Can I use it? And usually you can go from the bottom up and check, like, is the infra okay? Are the servers running? Is maybe the connection to RAN even there, or has it broken somehow? Then you go up to the Kubernetes level, and you can check simple things as such, like, are all pods even up? Are some of them not running? And if everything seems okay, then the only solution you have, of course, is look at the application logs itself, like the transaction logs, like 5G signaling protocol, and of course the real application logs as well, where maybe they report a problem, maybe they don't. But if you do all these steps, you really have a great understanding of why is it happening and what can I do to change whatever I don't like about it, for example, having high latency or crashing applications. And the other option, which we're also using, is to receive the answer directly. And the answer, obviously, is 42, always. But the problem is that we don't really know the question. So we have machine learning in place, and it's telling us, hey, something is out of the ordinary, like something doesn't really look right. Please take a look. But maybe we don't even know why that's happening, and worse, we don't even know what to do against it. So this is the top-bottom approach, and the other one is bottom-up approach. And it has to meet somewhere in the middle. I'll explain a bit more in a few slides from now, so please bear with me. And there's one metric which I like. This is showing the successful and failure registrations at the AMF level. And unfortunately, the lower bars, like the really tiny ones, that's like 8%, 10% something, this is the successes. So this is a horrible state, right? Everything is failing, and so on and so forth. The problem here is if a device, for example, attempts to register with the AMF and is rejected for valid reasons, for example, it's not allowed to use 5G SA or something, this is counted as a failure. So what does it tell us? Well, we have a lot of data inside here, but this data is not really that useful to determine if the application is working, because this is perfectly fine. It could be 100% KPIs on everything else, but this one, okay, so we did some evaluation, and it's cool to look at it, but not that useful, in my opinion. So this is the evaluate step. About the machine learning, for example, we receive emails like this one. This is, again, the SMOPS platform. The machine learning jobs tells us, hey, there's a metric, it's called LTE something, so we know it's related to MME component, to 4G, and it's way higher than usually. And this is registration attempts in this case. But the problem is, if you receive this out of the blue and you've never seen it before, you have the same problem again. Okay, you know something there is wrong, but how to fix it, where does it come from, and then you need to go back the steps and trace it back to, in worst case, hardware level, or maybe some broken connections to run. So of course, we need to take action, and now it's going to be a lot more broader than before. What do we need to do if we have all the data? Well, we've seen that we need to automate all the interactions, especially with everything legacy, especially with things like the RAN, and of course also with the paperwork. Because every time we do a change, and we want to do the small incremental changes, we need to notify a lot of systems. Like we need to notify our own first line and say, hey, don't worry, this is a planned change, we have everything under control. We can collect this, for example, from Helm chart hooks. If it's a pre-upgrade hook, we can just silence the alarms that are going to inevitably show up. We can collect it from Kubernetes events. And like one small nitpick, even the change requests, right? We have change advisory board, change needs to be created, sent to them, they need to be asked, hey, is this okay? Can we do it in this time frame? Well, if we do 8 or like maybe 50 changes in a day, which is maybe the goal with all the cloud nativeness, we need to automate that as well. There's no way around it if you have multiple clusters and want to do it. Like, it's in no way possible to do this with a manual work and maybe create some Excel sheets or PDF files and send it via email. And of course, one thing you have to do is exercise. You need to do worker node roles. That means replacing old machines with new machines, but with probably a higher level of kernel patch level or something else changed. You have stuff like chaos mesh and the friends to do some chaos testing, just kill some pods, see if the application is as resilient as you're hoping to. Do a lot of small changes to the environments, really get to know, is this change something I could do in the middle of the day when everyone is on their phones, or do I need to maybe shift it to the night? Of course, this is not what we want, but might be the current situation. And of course, you really need to check, like, is the change hot reloadable? That means, like, can I run it without any application even taking a restart? Or does it include a pod restart? And if the pod restarts, what does that mean for the customer? Because that's the only thing that we should be really worried about in the end, right? And as an example, at one point we ran like these node roles, like completely replacing the entire hardware supporting us for like 5 days in a row. So we really had then all the data, like, and hey, what are we knowing? What can go wrong? What doesn't usually go wrong? And also to, of course, to train machine learning, because it should be able to know, hey, this is a node role and this is expected result. A bit of the outlook, talking about how to deploy, tooling, and some key takeaways, hopefully. So deployment strategy, there's one proven way in which everything can work, and that is, of course, you take one core out of service, you drain it, you wait until there's no customer left running any session on it, and then you delete everything. And then you let, for example, worker node replacement happen, or you just run the software update that you're supposed to run, and then you wait a bit and you profit. Because if something goes wrong, well, no customers on it, no one cares. You can always bring it up later if you're sure that it's sane and the config is working and so on and so forth. But the problem is this takes a lot of time. And if you want to keep up to date, for example, with security patches, you're not going to be able to like only do deployments once every couple of weeks or something else. So of course, really, we want to be cloud native. And because this is not a goal to be cloud native in itself, but the goal is to be able to, for example, fix security problems fast. And please take this with some humor, because this is a collection of the worst things that happened in the past, and it's not happened all at the same time, and it's like not to be taken that serious, but you start your rolling upgrade of either infra or application, and then you run into a Linux kernel bug that you never heard about before, and it only happens in your specific circumstances. And then maybe you notice that there's some undocumented breaking change in some component, proprietary or open source, and suddenly nothing is working anymore. That's kind of bad. Then you notice that you have a problem with multus. Like, I believe this is the part where applications are not really cloud native, and let's see if the Kubernetes path will change it. And then you get a call from your boss over fixed line because mobile is no longer working. That's a problem. And then you promise that next time it will really work. Next time it will be better. And hopefully you're right, because I think that's still the goal, where we want to go. So one short exercise about tooling. Like, we're really interested right now in Cilium. We are really interested in this enhancement request about multi-network requirements that will make multi-networks first-class citizen. We already heard it before today. Of course, NWDAF. Maybe log shipping, I told you before, this is not the end of the road, maybe. weaveworks is working on this Helm cluster state drift detection, which is interesting, and in the end, maybe it will turn out we'll have to write our own operator. Maybe it's worth it, let's see. So, some key takeaways. Observability is never finished. This was the main topic, right? Let's see how far we will go and where it will bring us. And the cloud ecosystem is huge and heterogeneous. Like we have, I don't know, hundreds of pods, different kinds of software, some proprietary, some open source. Some of them have problems, some introduce new problems, some fix old ones. Who knows? There's a big change always. And the cloud nativeness is not a goal, it's a tool. Like we want to have the tools to not be forced to stand up in the middle of the night to make updates. We want to do it during the day. And we want to be fast, for example, with security patches, and this is maybe the right tool for it. Let's see. So cloud native is really difficult, but desirable. That's where we want to go. And interface to legacy, including all the paperwork. That will not go away, so the only solution is to automate most of the things, or all of the things, and that's something we need to tackle as well. So thank you for your attention. And I'm not sure about the question part, because Vuk mentioned it's going to be hard. But of course, we're also up for questions if you have some later.
I'll, again, please, with a round of applause. I'll again need to improvise. Thanks, Dorian. Thanks, Roman, for the presentation. I have obviously some insights into what these guys are doing and might ask unfair questions. But can you reflect, it's obviously how it's going now. What were the major hurdles that you needed to overcome to come to this stage? So how it all began, and give us a little bit of retrospective, what you used before this and how is this helping?
Talking about observability or in general? Such a broad question. I joined this project last year, in the middle of last year, and the project was moving so fast that there was little in place. Like there was alarming, and there was the cluster local Grafana everyone was looking at all of the time. And that means, of course, you need to log into one specific Grafana for every cluster. So I think the biggest win was moving everyone to one common sink. And you can see all of the clusters in one dashboard and can determine, hey, I don't even need to look at that one because that looks perfectly healthy. So I think this was the biggest win on that side. Tooling, I don't think we're at the end of the road. There's still a lot of work ahead, especially in syncing with First Line and the other colleagues. Not really sure if that answers the question.
Yeah, definitely. Another one in terms of, you mentioned the tracing and SBI interface, Jaeger, that's okay. How about the telco protocol tracing, not within the cluster, but end-to-end? What's the experience and what's the way of working today and where it's going?
Yeah. The problem with the legacy protocols, of course, HTTP, diameter, and all the stuff, right? So we are still forced with our 5GSA core, including 4G, right? We are still forced to use PCAPs or tracing in that matter. So it's simple as before, right? Something in the switch, you put it in there, and then you just kind of get the same packets the network function then will receive. So still old. Hopefully it will getting better. Of course, this is also an effort for the vendor to implement fancier things, which then do not need something on network side, because if you imagine you want to scale it or whatever, right, or you want to bring it to new servers, implementing something like this could be hard because a technician needs to go outside and or via remote, whatever, and need to configure that, right? So, and everything which can be do in an automated fashion is, of course, the best way to do it.
Thanks, Roman. Last one, or actually it's more a comment. In the Kubernetes, logging to the standard out from container from the pod is a kind of expected thing, no-brainer, normal thing. Was that, in your case, always like that?
Asking the mean questions. So I will not name the specific vendor, but basically I've been told that if they cannot log directly to some host mount path, that they are not able to have any insights anymore. This was some time in the past. We've fully moved to standard out, but we had to push the vendors in this case, and I think it's a good sign that they're being pushed and that they're allowed to push it, and hopefully it will help everyone. Like, we don't want Deutsche Telekom specific solutions. We think there's general solutions that will help everyone, including the vendor, and that's what we're usually pushing for.
And in the slide from Vodafone, we had this hand in hand, right? So it's exactly what we need here, right? We as Telecom or as Vodafone, we do not go to Ericsson and Co. and say, please implement it like that, right? So this is not working. We need to do it hand in hand and improve forward in maybe even a DevOps way with the infinity loop. So yeah, I think that's the goal we need to do, and that's also the paradigm shift in the heads of all the telco vendors and the managers there. We need to